Welcome to another lesson on using the zeros or roots of a quadratic function in order to determine an equation of the function. We've already done this using factors of a quadratic, but now we're going to use the sum and product of the zeros or roots to determine our quadratic function. So to start off, remember the zeros or roots of a quadratic function are the x values for which the function f of x is equal to 0. So if we have a quadratic function that has zeros r sub 1 and r sub 2, that means x minus r sub 1 must be a factor of our quadratic function, and x minus r sub 2 must also be a factor of our quadratic function. And a can be any constant. Notice if a is a constant, it does not affect the zeros of our quadratic function. And unless our quadratic function ends up having fraction coefficients, we'll always let a equal 1. Now we're going to multiply these two binomials and see what we notice. So if we multiply, we'll have x squared minus r sub 2x minus r sub 1x plus r sub 1 times r sub 2. Now let's focus on these two middle terms. Notice how they have a common factor of x and they're both minus. So if we factor out the minus as well as the x, we can write this as minus the quantity r sub 1 plus r sub 2 times x, and then we have plus r sub 1 times r sub 2. So for a moment, if we assume a is equal to 1, notice that if we find the sum of the two roots minus this sum would give us the coefficient of the x term, and the product of the two roots would give us the constant term of our quadratic function. So now we can use the sum and product of the zeros to find a possible quadratic function. Let's go ahead and give it a try. We want to find an equation of a quadratic function that has zeros -1 and +7. So we're going to sum the zeros and put that number here, and then we'll find the product of the zeros and put that here. So r sub 1 plus r sub 2 is equal to -1 plus 7 is equal to +6. r sub 1 times r sub 2 is equal to -1 times 7, which is equal to -7. And because we're not going to have any fractional coefficients, we'll go ahead and let a equal to 1. So this is all we need in order to find a possible quadratic function. We'll have f of x equals, again, a is equal to 1, so we can just drop these parentheses. We'll have x squared. Now notice that r sub 1 plus r sub 2 is +6, so we're going to have minus 6x. So our coefficient is really -6. And then we'd have plus our product, which is -7, but instead of plus -7, let's go ahead and just write -7. And this is our quadratic function that has the given zeros. To verify this, we can graph this function and make sure it has x-intercepts of -1 and +7. So here's the graph of our function. And again, notice it does have an x-intercept of -1 and +7, verifying our function is correct. Let's take a look at a second example when the zeros are fractions. We want an equation of a quadratic function that has zeros -1/2 and 2/3. So again, the first step, we want to find the sum of the roots or sum of the zeros, and then the product of the zeros. So r sub 1 plus r sub 2 is equal to, so we'll have -1/2 plus 2/3. Here we'll have to have a common denominator, which would be 6. So we'll multiply this first fraction by 3/3, second fraction by 2/2. Notice how we have a common denominator of 6, and then we have -3 plus 4. So the sum of the roots is +1/6. Now we'll find the product. So we'll have -1/2 times 2/3. Notice how here we have a 2/2 that simplifies to a 1. So our product is -1/3. Now notice how we are going to have fractional coefficients unless we select an appropriate value for a. So when we set this up, we'll have f of x equal, we'll come back to our constant, times x squared. Then it's going to be minus the sum of the roots, so minus 1/6 x, and then plus the product, plus -1/3, we can write as just -1/3. Now again, if we don't want fractional coefficients here, we'd have to multiply through by the least common denominator, which in this case would be 6. So let's let a equal 6, and now we'll distribute. So f of x equals 6x squared. Well, 6 times negative 1/6 is negative 1, so I'll have minus 1x, or just minus x. And then 6 times negative 1/3 would be negative 6/3, which is negative 2, so we have minus 2. This quadratic function has zeros of negative 1/2 and positive 2/3. And again, to verify this, let's graph it and check our x-intercepts. Notice how we have an x-intercept of negative 1/2 here, and it's hard to tell, but this does look like an x-intercept of positive 2/3, verifying our work. Okay, in part 2 we'll take a look at what happens when we have imaginary and complex zeros, but we can still use the sum and product of the zeros in order to find our quadratic functions. I hope this was helpful.